Hello class, this will be the last section of chapter 14, linear motion, but now dealing with some trig functions to go along with it. So just some review, if we want to look at what A of t was, remember that's just acceleration. V of t is velocity, so velocity is movement, acceleration is the change in velocity, and then S of t is position. All right, so position, displacement, distance, what's the difference? Position is that separation between an object and a reference point. I could say I'm 25 feet from something. Now, displacement is representative of the change in position. So how am I changing with reference to that 25-foot distance away? And then distance is the amount an object moves. So putting all these together, if given velocity, how can we find displacement? Well, if we have the velocity, the displacement is going to be the integral of our velocity function. All right, so this is a key piece. When we're working trying to find displacement, it is the integral of velocity. But now if we're talking distance, distance is going to be the integral of the absolute value of velocity. All right, so we want to know, so displacement, if I walked from school to Wesco and then walked back, my displacement would be 0. But now if I wanted to find the distance, that would be absolute value. If I walked from school to Wesco, say it's 4 miles, and then walk back to school is another 4 miles, and so I would travel a distance of 8 miles, but my displacement would have been 0. All right, so let's talk a little bit more about movement. Okay, what can we say about velocity when the particle is at rest? So velocity is dealing with movement. So at rest, my velocity is equal to 0. When it is moving right, my velocity is positive. When I'm moving left, my velocity is negative. And my speed is the absolute value of velocity. So let's take a look at an example. Particle moves horizontally. The displacement in minutes is given by the displacement function S of t, 5 minus 2 cosine of 3t, where t is in seconds. If I wanted to find the velocity function, that would be the first derivative. So my velocity is going to be derivative of 5 is 0, negative 2 times, now this is chain rule, so cosine of 3t is going to be a negative sine of 3t times 3. And so this becomes a positive 6 sine of 3t. That is our velocity function. To find the acceleration, we're going to take the derivative of our velocity function. So again, our velocity function was 6 sine of 3t. So our acceleration is going to be 6 is going to come along. We're not going to do anything with that. Derivative of sine is cosine of 3t times 3. So it's going to become 18 cosine of 3t. Find the particle's initial displacement, meaning position, velocity, and acceleration. So initial displacement, this is going to be when t is equal to 0. All right, so if we want to look first at our position, so S of 0, it's going to be 5 minus 2 times the cosine of 3 times 0, which ends up being just 3. Cosine of 0 is 1, so it's 5 minus 2, 3. and this is going to be in meters. If I want to find the initial velocity, this is 6 sine of 0, which ends up being 0 meters per second. And my acceleration, a of 0, is going to be 18 times the cosine of 3 times 0, which is still just 18. Now my units are meters per second squared, because it's the change, the rate of change of velocity. So it's meters per second per second. When is the particle moving left, right, and stopped during the interval from 0 to pi? All right, so first off, let's figure out, so movement, we're talking about velocity. I want to know some critical points. So when is v of t equal to 0? All right, so when is v of t? And remember, our v of t was going to be our 6 sine of 3t function. So if I want to set that equal to 0, if I divide by 6, I still end up with 0 equals sine of 3t. So let's just look where sine is equal to 0. Well, I know sine is 0. So sine of 0 occurs at 0, at pi, at 2 pi, at 3 pi, and I could keep going on and on and on. Okay, but I'm focused on where 3t is equal to 0. So 3t is equal to 0 when t is equal to 0. 3t is equal to pi when t is equal to pi over 3. 3t is equal to 2 pi when t is equal to 2 pi over 3. 3t is equal to 3 pi when t is equal to pi. All right, so I can make my sine chart to be able to work. And I know, let's go at 0, at pi over 3, at 2 pi over 3, and at pi. So that encapsulates everything on our interval from 0 to pi. So now we have to start checking points. Well, if I pick a point, we'll say here at pi over 6, so my velocity at pi over 6 is going to be 6 times the sine of 3 pi over 6. 3 pi over 6 is the same as pi over 2. Sine of pi over 2 is a positive 1, so I know then I am positive when I am less than pi over 3. If I chose a point between pi over 3 and 2 pi over 3, we'll say pi over 2. If I check this one out, it ends up being negative. And if I chose another point, let's say 3 pi over 4, if I do this, it ends up being positive. So now, to answer the question, when is it moving left, right, and stop during the interval? I know it's going to be moving right on my interval from 0 to pi over 3, but also from 2 pi over 3 to pi, and it's going to be moving left on my interval from pi over 3 to 2 pi over 3, all off of our sine charts. Last one, what is the total distance traveled during this? Well, total distance, we know is that absolute value. My interval is 0 to pi. Absolute value of my velocity, dt. And so this ends up being my integral from 0 to pi. Absolute value 6 sine of 3t dt. When I work this out, I can do it directly in my calculator. It ends up being 12. So the distance traveled be 12 meters is how far this has traveled. So that's it for chapter 14. In Schoology, I have some practice problems to work on, and then we will get started on vectors in the next video lesson.